What if I told you that you don't exist? Would you say,
"You stupid"?
you may be a bunch of code mimicking a living person? Or am I just an elaborate program created for your amusement? You probably heard those words. We live in a simulation. But is it true? Is it even possible? Is there any proof? I wonder it myself. So let's ponder some scientific and philosophical questions surrounding this topic. Are you in? Which will you choose? Blue pill or red pill? Okay, first of all, you can take off your tinfoil hat. This is not a conspiracy video. I will talk about topics that are common in this type of videos, but focus more on questions and reasoning behind them. I want to look at trends, current state of technology, and what could be possible in the future. There is also the aspect of metaphysical subjects and coincidences existing in our universe. I am not an expert in this topic, and all talking points in this video are highly hypothetical. So, what even is the simulation theory? Simulation theory states that what we perceive as existence is not real, but a simulated reality. Just like in a video game, everything around us may be generated by a computer, and we are unaware of it. Either we are programs made to experience consciousness and humanity, or we are trapped in endless simulation, carefully crafted to resemble actual life. The theory peaked in popularity at the end of 2018, mainly due to Elon Musk's appearance in Joe Rogan podcast.
This could be some simulation. It could. Because if you assume any improvement at all over time, any improvement, 1%, 0.1%, just extend the time frame, make it 1,000 years, 1,000,000 years. If you assume any rate of improvement at all, games will be indistinguishable from reality. Therefore, we are most likely in a simulation.
Does this give it any eligibility? Judge it for yourself. Especially since this moment was also in this episode.
That's all it is.
Astrophysicist Neil deGrasse Tyson also talked about simulation theory.
Chuck, I've been public on the fact that I'm waiting for someone to convince me that we don't live in a simulation.
I've heard you say it.
The arguments put forth have been quite convincing to me.
There is no concrete proof that it is true, and probabilities are at best a big approximation. We can say that everything is possible, and with specific variables, it may even sound like all the things align to support the theory. Like if I said that universe was created by some mythical, omnipotent being, because there is no way for something so complicated to exist by itself. And through a chain of events lasting billions of years, we have 6 million movies. Coincidence? No, this has to be a proof, made in an image of Almighty. Is this the second coming of Christ? You cannot disprove it, so does this make it true? If you have been interested in this hypothesis, you probably heard this name. Nick Bostrom, Swedish philosopher with expertise in topics such as existential risk, artificial intelligence ethics, superintelligence, mind and consciousness emulation. It can be said that he is the father of the simulation theory. In a paper released in 2003 titled "Are We Living in a Computer Simulation?", he presents 3 scenarios. 1. Humanity is very likely to go extinct before reaching post-human stage and be able to create simulated reality. 2. A small fraction of advanced civilizations is interested in simulated universes due to technological, ethical, or economic reasons. 3. There is a high chance that we currently live in a simulation. It is an interesting read, focusing on the philosophical side of this theory. All of it hinges on 2 big assumptions. Civilization can reach sufficiently advanced technological state to make hardware and software able to run simulation indistinguishable from real life. And it is possible to simulate consciousness. So how does this play into all possible scenarios? Let's find out. It cannot be done. There are many reasons to believe that it is impossible to create an artificial reality.
Wake the fuck up, samurai.
Our universe is a gigantic mess. We can look at video games and compare how much more complicated this task would be. Enormous number of diverse objects and avatars, countless amount of random and predetermined interactions, scale and complexity of universe, entire physics system. All of it require work to be created and computing power to operate. It seems impossible to be made by humanity alone. So the best thing would be artificial superintelligence. AI at the current state can't conceive new ideas. It learns from already existing inputs. The thing is, it is not certain if it is even possible for AI to reach this point. We don't even know how exactly does a human brain work. Is it just a bunch of neurons and signals, or is there something more? If we made an identical copy of a body, atom by atom, would it experience the same consciousness as the original? Can it be replicated using silicon microchips instead of carbon-based neurons? And even then, how do you power a supercomputer? AI companies consider building entire nuclear power plants for research and development. Even with a better technology, a machine able to simulate entire universe would require so much power that alternate energy sources are necessary. Cold fusion, Dyson sphere, harvesting power of entire solar systems. And how do you get all the materials to build a supercomputer, including data storage, power source, and cooling system? How big this megastructure would be? I don't think that we can estimate it right now, without even knowing what is needed to operate superintelligence on a smaller scale. Also, it is speculated that conscious artificial intelligence may be our last invention, deeming us as dangerous or obsolete to its own survival. And that is a better scenario, in which we don't destroy ourselves or all die in an apocalyptic event long before creating it. On the other hand, what would be the reason to make a simulation? All of the resources can be used in other ways. In a movie, The Matrix, humans are put into simulation by machines to use as a power source. It is not ideal. Energy is wasted to run other bodily functions. A better idea is to create a biomass converter. Even this is not efficient enough. Harvesting power straight from a star is more optimal, and technology shouldn't be a problem. Maybe simulation is a tool made to harvest brain power. Our creative thinking could be used by a computer. In this scenario, it is not a full simulation, since the subject exists and is only put into an artificial world. So, a supercomputer is like a director, steering a mind in a way that fits his vision. Other people can be either also trapped in a simulation or be made up and only act like real beings. But this means that superintelligence don't exist and that AI cannot emulate consciousness. So, is it some elaborate ploy to control the masses? There are easier methods. Is it some form of sick entertainment? With advanced technology that allows to create such complex simulations, we could as well inject happy chemicals straight to our brains. And if we don't even exist, being fully simulated, what are the benefits of making the entire universe? If this AI is able to do this, it should be able to achieve the same things as humanity, but even faster. There is no apparent reason to make a simulation, which means to make it, all things that can be achieved inside should also be possible outside, unless the reason for it is beyond our comprehension. That's why there is possibility that we live in a simulation. All the previous points assume that creators of a simulation live in a universe same as ours, but this may not be the case. Our reality may be just a fraction of a greater, more complex existence. This would give makers a full control over us and allow doing things that are in theory not possible. In our understanding of how the world operates, we have encountered many limiting factors: Planck's number, absolute zero, gravitational radius, and the speed of light, for example. Let's take the speed of light. It is the theoretical maximum speed that we could hope to achieve someday. Light and more precisely photons, can travel through space reaching a velocity of over 1 billion kilometers per hour, or 671 million miles per hour. For us, it is hard to imagine. We can only achieve fractions of it. But in the universal scale, it is laughably small. At this speed, the length of Earth's equator can be traveled in less than a second. Distance from the Sun to our planet in 8 minutes, and to the end of the solar system in around 5 hours. Then it becomes more apparent how limiting it is. From the Sun to the other closest star, 4.2 years. Across our galaxy, 87,000 years. And to the next closest galaxy, Andromeda Galaxy, 2.5 million years. It takes 2.5 million years, traveling at the speed of light. It is a big limiting factor when we consider the prospect of space travel. Some say that it could be the maximum render speed of a simulation. Limiting it would allow generating new terrain ahead of an individual traveling at maximum velocity, and the rest of physical constraints may restrict other factors: minimal size of matter, the lowest temperature, highest possible mass concentration. All of those things may be there to limit our interactions with a simulation to a manageable scope. The simulation is made in a way that we would never know that we live in it. We cannot do anything about it, because the program itself doesn't allow us. Then, could we create our own simulation? Maybe, but it would be limited by what is already possible, and stacking of simulations may overload the original one. Even if we reach the point at which we could make it, our simulation may be just wiped or reversed to the beginning. So, is there no way to know? In a perfect simulation, no. But there may be signs, glitches and oddities, breaking the illusion, like dreams being a way to look beyond a program, or just a way to defragment our brains and rearrange stored data. Going into a room and forgetting what you had to do could be caused by memory faults. Deja vu as loading a previous save state. Mandela effect as changing a small detail in the simulation.
What a skilled gamer. Jeez, oh my god.
Or even bizarre world events as a form of entertainment, like a Netflix show. Obama. Those are fun things to consider, falling more in a meme category, far from the actual proof. But you may have heard that there is a higher chance that we live in a simulation than not. This statement is based on a notion that we are more likely to be at the end of a chain in a simulation tree than on the beginning of it, as right now we can't create realistic simulation, so we are either the first beings to make it, or we are at the end of a chain, or we are one of the failed attempts at replicating reality, unable to make it ourselves. So to be the first in this simulation scenario is magnitudes less likely to be somewhere else on this tree. Is it a proof? It is still a hypothetical scenario, and until we see that it is possible to make an artificial reality of this magnitude, we can't conclude that it is true. The next possibility is that we are special, and first to do it. So, we can create a simulation in the future. Right now, it is nothing more than a dream. There is a handful of rapidly developing technologies that may play a big role in this endeavor. AI is the hot topic at this moment. Looking at what was possible a year ago and now, it seems like an entirely different beast. The thing is, we don't know how far it is from achieving consciousness or even a resemblance of it. Technology not always develop at the same pace. Big advancements and rapid growth are easier at the beginning, but become much harder the later we go. Soon, we may hit a wall, and scaling computing power and size of data centers may not be enough to achieve a significant breakthrough. Overall, AI is a huge piece of a simulation puzzle, which would allow for quick generation of various assets, simulation of all interactions between them, or to run and optimize all the necessary code in the background. Integrating this technology in other fields of science can also be beneficial, and significantly speed up overall technological progress. The other interesting factor is video games. We could say that this is the closest we are right now to the simulation. Same as with AI. During the last 30 years, we made a huge progress in realism and complexity of games. Better and better graphics, more elaborate algorithms, and different ways of achieving immersion. What is available to the average consumer is nowhere near the possible maximum power. Video games are optimized to run on a commercial hardware. Ongoing development can bring many benefits to the creation of a simulation. New, faster ways to generate objects, levels and characters, random generation, and implementation of machine learning, all of it can be used. Even tricks used by developers to reduce system requirements can be used in a simulation. For example, in a video game, it is not necessary to render everything at the same time. Anything that is not seen by a player can be stored in a memory and loaded in only when needed. We could make so the simulation does the same. You don't need to know what is in the next room at all times, but only when you walk in. The same thing can be applied, but on a bigger scale, increasing the complexity only when the player interacts with something. VR, haptics, Neuralink, devices like this can provide new ways to interact with the digital world and let us gather the necessary experience. The next important technology that is currently under the development is quantum computing. From time to time, new articles pop up saying how much faster quantum computers are compared to classic computers. They can be exponentially faster, but only at specific things. Most of the time, normal computers are just better. Quantum computers are better suited to deal with problems regarding material science, encryption, analyzing large datasets, DNA sequencing, and running complex physics simulations. This technology is in an infancy stage, very costly, limited, and hard to use. But in the future, combining classic and quantum computation may allow to greatly increase the speed at which computers operate.
Wow!
In the energy sector, fusion reactors are a promising new development. Currently, nuclear energy provides the best bang for the buck. Nuclear energy, and more precisely, nuclear fission energy, comes from atoms, a heavy element. For example, uranium-235 is struck by accelerated neutron. Then it splits into lighter elements and free neutrons. During this, additional energy is released and can be harnessed for other uses. The process is self-sustainable. Released neutrons can hit other heavy particles, splitting them and causing chain reaction. This may cause unwanted accidents.
Not great, not terrible.
Nuclear fusion can be summed up as
The power of the sun in the palm of my hand.
it uses the same processes that happen inside our sun. Light elements are combined using high pressure and temperature, fusing into a heavier element, releasing some free neutrons and energy. Unlike nuclear fission, neutrons can't cause a chain reaction, making this process a lot safer. Fusion reactors use isotopes of helium, which can be manufactured and obtained in higher amounts compared to uranium. Right now, fusion reactors are not really a thing, but new advancements allowed us to recreate this process on a smaller scale, even producing some net energy. In the future, when this technology gets developed further, we could have access to a safer and more abundant energy source that produces less radioactive waste. The good thing about AI, quantum computing, and fusion is that progress in one technology can have a synergetic impact on the others. All of those things can allow us to reach new technological heights, making the simulation a real possibility. So, what is the verdict? Do we live in a simulation? Can we create it? Or is it impossible? I think that the most probable scenario is that we are going to create it in the future. But if we are able to make a simulation, chances that we are living in a similar simulation would skyrocket. Right now, there is no evidence for any scenario to be more probable than the other. Each hypothesis hinges on assumptions. Many arguments can be presented to support each possibility, but they often contradict each other and cannot be proven. Even experts say that chances are equal. Until we reach a point of truly thinking AI or create a working simulation, we can say anything for sure. In the end, no matter which option is true, it doesn't change anything. I put some interesting articles and papers in the description. If you want a more in-depth look at this topic, I suggest looking at Bostrom's publications. You can check out my other videos, like this one about fourth dimension, or this one about magnets and electromagnetic force. Subscribe and leave a like. Feel free to comment your own theories, and see you outside the simulation.
Discombobulate.